Hello. Today I'm going to be doing a concept video. Oops, got my water. Ugh. A concept video on astrophysics, just kind of going over some of the basics about the universe, about its structure, about different kinds of stars, life of stars, all that. Yeah. So, first, let's talk about the universe. So the universe is pretty large, very large actually, and it's constantly expanding. And in comparison, we are tiny, tiny little bits of stardust. Anyway, so our solar system is the first gravitational unit. So this means that all the bodies in our solar system are gravitationally connected. So the 8 planets that are gravitationally connected are Venus, Mercury, Mars, Earth, Jupiter, Saturn, Uranus, and Neptune. And all 8 of these planets are orbiting a massive star, the Sun. So, here's the Sun, all the planets orbiting around it. So these orbits of these planets are elliptical. That typically means oval-like, but for most of these planets, the orbit is pretty close to circular. However, planets aren't the only thing orbiting the Sun. There are also asteroids that orbit the Sun. Those aren't considered planets, though. Also, moons orbit other planets, but they are not considered planets either, because a planet is defined as a body in orbit of a star. So, because moons are orbiting planets, such as the Earth, Saturn, Jupiter and Saturn, they're not considered planets themselves. Earth has 1 moon. It's called the moon. Kind of boring. Saturn and Jupiter have many moons, and they have different names and everything. Alright. Oh yeah, our Sun, big giant star, center of our gravitational unit. It's part of a galaxy called the Milky Way galaxy. So what a galaxy is a collection of stars, and they attract each other through gravitational force. And there are 3 different types of galaxies. Ooh, I'm supposed to be drawing a picture. There are spiral galaxies, elliptical galaxies, and irregular galaxies. So this probably isn't going to be very accurate, but I'm doing my best. So the Milky Way galaxy is a spiral galaxy, kind of like this, kind of not really. So in the middle there's a rotating disk of stars and interstellar medium, and there's little spirals, and they're the galaxy's arms. So an elliptical galaxy is... I'm sorry, I'm not an artist. But this is kind of like an elliptical galaxy. It kind of varies in form depending on the galaxy. So this is kind of the middle, the interstellar medium and all the stars, and there's like arms extending out. But they don't spiral as with a spiral galaxy. And then there are irregular galaxies, which have no specific structure. So, I don't know. Woo. Irregular galaxy, because, I don't know, they're irregular. So, now let's move on to stars. So, the most well-known star in astronomy is the Sun. Giant ball of burning gas. It's at the center of our solar system and is also a part of the Milky Way galaxy. However, it's only one of billions of other stars in the universe. So stars are formed when there's interstellar dust kind of floating around, and it's pulled together through mutual gravitational attraction. And, it's pulled together quickly, and a lot of potential energy is lost. So the kinetic energy is produced, and fusion is able to occur. So, and then when the fusion process occurs, it releases enough energy that the pressure created through this, there's like outwards pressure pushing out, and that prevents the star from collapsing because of gravitational pressure from the outside. Alright, the most important thing about a star is its mass. Mass of a star that is fusing hydrogen into helium, that's a normal star, determines its luminosity and its temperature. But its initial mass can also determine the fate of a star, what it's going to end up doing eventually. Alright, so I'm going to do this quickly here. There's a diagram called the Hertzsprung-Russell diagram, and it kind of shows you where stars are in terms of luminosity, in terms of magnitude and temperature. So let's see, I'll put temperature up here. I think luminosity goes here, and magnitude. I'll check this later if I'm wrong, I'm really sorry. So I'm sure you'll get a copy of this at some point, but it's kind of backwards right now, but this is kind of a really rough version of it. So it divides up the categories of stars based on these things. So this little awkward looking line is the main sequence of stars. The sun is in the main sequence. I think the Milky Way is in the main sequence. And down here in this corner, this is the when you're looking at the diagram, it's the left-hand corner, lower corner, and those are the white dwarf stars. And up in this upper right corner, there's red giants and supergiants. They're kind of grouped together, but yeah. So I'm gonna pop this over here. So in general, there's a kind of formula for how stars are going to develop and what their eventual fate will be. So first, the star is formed, and then it becomes the main sequence star. You know where the sun is. Then it will become a red giant, a white dwarf, and then a supernova and a neutron star, depending on, what happens to it eventually. So red giants, they're in the upper right corner of the HR diagram. That's what we call it for short, because Hertzsprung-Russell is kind of a mouthful. They're large, cool stars, and, as in temperature. And they have a reddish appearance. Inside the star, helium is being fused into heavier elements through nuclear reactions. So all main sequence stars from, the big dash in the middle will evolve into red giants. After red giant stars, the stars will become white dwarfs. So basically at the end of a red giant's revolution, it loses most of its mass and leaves behind a really small, dense star, in which there are no nuclear reactions. White dwarfs are very hot, but not very luminous since they are pretty small. They're about as massive as the sun and about the size of the Earth, so that's how dense they are. The sun is much bigger than Earth. And, yeah. So after or among these stages, many things can happen to a star. They can explode into supernovae, form neutron stars, or even black holes. So a supernova occurs when a star explodes and creates a luminous object. So most of the star's material is expelled at high velocity and creating a shockwave that sweeps up a shell of gas and dust, and that's called a supernova remnant. So a supernova is a very bright explosion and it'll fade out over a few weeks or months. This is really cool. It radiates about as much energy as the sun would emit over 10 billion years. Very bright, very hot, very brief. So neutron stars are another fate of the star. So neutron stars are formed from the collapsed remnants of a massive star. So usually supergiant stars, which are very big red stars, collapse and form neutron stars. They contain mostly neutrons and are very hot. Finally, black holes. Black holes are really difficult to explain, but just the concept of black hole has like a point of singularity, which is this really massive point. And because it's so dense and massive, it causes extreme curvature in the region of space-time around it. Let me see if I can draw a picture here. So there's that. That's a point, and then there's curvature in space-time. Sorry, I lost my place. So black holes have large gravitational force because they're so massive and they can pull in just about everything, including light. So there's something called the event horizon of the black hole, and that's the place where nothing can escape. And it's a certain distance from the point of singularity. And that distance is called the Schwarzschild radius. And the Schwarzschild radius is the distance from the point of singularity where anything that wants to escape a black hole must move at the speed of light, which only light can do. It's the thing about the speed of light. And that's called the escape speed. So because black holes can pull in light, this makes them pretty hard to detect. So one way to detect black holes is if they interact with matter outside the event horizon. Oh my gosh, it looks like I'm about out of time. I guess I won't go into Cepheid variables or binary stars because that's less important, but those are the basics of astrophysics.